All right, hello. Welcome to the first video in this dynamic series. So we'll be covering a lot of topics. This is going to be the usual format. What I'm going to start with is a very general description of what these variables that we are most often dealing with, what these are, and very general properties, and we will take a deeper dive into definitions and conditions for any of these variables and how they are related to each other. So first, let's start with kinematics. We have some very basic definitions. The most basic one is position. Position, it's really not complicated. If you have a point, you point to the location of that particle and you call it position. Usually letter P or something like that, R, P, that works. Another thing you can define on top of position is the concept of displacement, which has a notion of time in it. So assume some time has passed. Before you were here, now you have come here. Before you were here, or now you're here, R prime. And you have moved this much, delta. Let's call it delta R. Delta R is how much you have displaced. You went from one point to another. So that is the concept of position. If there is some time that has passed, displacement, let's call it here. Some time has passed delta t, and you went from one point with some position to another point with another position. So you were here, or at the beginning, you went here at another location, R prime. This is your displacement delta R. Your velocity is how much you have displaced divided by how much time has passed. So velocity is very roughly speaking delta R over delta T. We usually use letter V for it. And that is velocity, change in position relative to the how much time has passed. And finally, acceleration is the concept of, now imagine you are here somewhere, doesn't matter, and you're moving with some velocity v. So velocity is what you usually expect in driving a car or riding a bicycle. You have some speed and you're going in a certain direction. That is your velocity. And after some time, you will have some other velocity, v prime. The amount of change in velocity, delta v, divided by time is your acceleration. So how fast you are changing your speed. If you go from 0 to 60 in 1 second, that's a lot more acceleration than going it in 10 seconds. So I have shown these concepts, positions, velocity, and acceleration, in a peculiar form, always using these arrows. See, everything was an arrow. All right, these. So position, velocity, and acceleration, all of them are position, velocity, acceleration are all vectors, vector quantities, meaning that not just the magnitude is important, how far you are from a reference point, but also in what direction you are relative to that, or in when it comes to velocity or acceleration, what is the direction of that displacement or change in speed. So all of these are vectors. Remember that, but as we will see in the next video, when we start simple, we can look at simpler conditions when a single scalar value is enough. One last thing I want to say here, position is a quantity that has the nature of length. So when we want to measure it, we measure it with units of length such as meters or feet or kilometer, mile, or whatever. Velocity is change in position. So position is a meter. Change in position, so you displace 2 meters, divided by time passed. So it is usually has units of meters per second or feet per second or kilometers per hour, miles per hour, and so on. And finally, acceleration is the change of velocity relative to time. So it has meter per second divided by second, or meter per second squared unit, or similarly feet per second squared, and so on. And again, one last time, I want to emphasize, all these quantities are vectors, meaning that not just the magnitude, but also the direction matters. So that is for now, for this video. Just very rough idea of what we mean by velocity and position, velocity, and acceleration. Let's go to the next video and talk about these quantities in specific scenarios. And we start with the simplest condition going along a straight line. So I'll see you then.